Hello, my name is Natalie Hedden, and this is my video project for derivatives. So as you can see here, this is going to be our example we'll use for this project. Our first step is to find the derivative, and then our second step would be to factor out that derivative. Now we're going to use these numbers in between, so 3, 5, and 7 in between our points of 4 and 6 to determine the increasing and decreasing for the intervals in between, which are 4 and 6. So we're going to plug those into each of the points to find the slope in this area. This can be seen here on this slide. We have each of those numbers plugged into the derivative. At 3, it is positive, which is an increasing interval from -infinity to 4. And at 5, it is negative, which is a decreasing interval at 4 and 6. And at 7, it is positive, which is -infinity to 4 and 6 and 6 and positive infinity. This can be confirmed on our graph that we have here. It is increasing from -infinity to 4, decreasing to 4 to 6, and then increasing once again from -infinity and 4 and 6 to positive infinity. Now we'll use our second derivative to find the concavity and point of inflection. Our second derivative from our primary example is 12x minus 60, and we're going to factor that out, which gives us x equals 5. And at 5, the concavity changes, and we will plug in the values from both sides, 4 and 6, to determine if it's concaved up or down. So once we've plugged those into our second derivative, we can see that it is -12, which means it's concaved down on the interval of -infinity and 5. And when we plug in the 6, we get +12, which means it's concaved up on the interval of 5 to positive infinity. This too can also be confirmed on our graph. As you can see here, it is concaved down and then concaved up. Next, we'll look at the limit as x approaches infinity. Now the cubic polynomial, it means that a will always be positive and limits follow the highest degree. So x to the power of 3 will equal infinity, and also as x approaches -infinity, x to the power of 3 will equal -infinity. Now we'll examine relative max and mins. We'll be using we can use the first derivative and the second derivative for this. Looking at our first derivatives, we can see that it goes from increasing to decreasing, thus having a relative max, and then decreasing to increasing, thus having a relative min. Now we can also use our critical points of 4 and 6 and plug it into our second derivative, which can be seen on the right. Plugging that in, we get plugging our critical point of 4 in, we get -12, and plugging our critical point of 6 in, we get +12, meaning that our relative min is 6 and our relative max is 4. And we can find these exact points by looking at our graph on Desmos, we can find our relative min point is 6, 215, and a relative max of 4, 223. Thank you.